Hello CS112, today I'll be going over Lab 12's def recurse length. I didn't really paraphrase the instructions like I normally do above because this was a pretty straightforward assignment where we had to replicate the built-in length function, which we all know and love, recursively. So as you can see here, we're going to be our input is always going to be a list, and we have to return how many elements are in the list one-dimensionally. So as you can see here, I copy and pasted the three test cases that were on the assignment PDF, as well as I created my own, which you guys should be doing too, because we're all super seasoned veterans at programming by now this late in the semester, and I wanted to test it out with a list with different types of elements. Obviously, this should return 5 because it has a size of 1, 2, 3, 4, and 5. This entire, my last element is actually a list, but it should work the same. So when thinking about an algorithm of how we can do this, I sort of thought about this like a bag of M&Ms. So let's look at this for instance, 1, 2, and 3. If I wanted to count how many M&Ms were in my bag, first obviously I'd open my bag and then I'd look inside. When I'd look inside, I would have 1, 2, 2, and 3, which are can represent M&Ms. I'm going to eat one of them, right? So plus 1 in my stomach. Then I'm going to have only 1 and 2 left. I'm going to eat another one of them, so that's our plus 1 in my stomach. Then I only have 1 left, which I of course will eat, and then I will have 0, or an empty list, an empty bag of M&Ms, which is very sad, so I will plus 0. So as you can see here, I'm keeping track of how many items are in the list by simply having one of them removed. This was the most common algorithm that you guys used, and a lot of you guys got this hinted off of what you're allowed to do. And among the allowed things, one of them was the pop method, and the other was you guys were allowed to do slicing. And specifically for slicing, I saw a lot of you guys, let's say your list's name is a list. A lot of you guys were whipping out this method, which is the opposite of what pop is doing here. Instead, it's going to be eating M&M number 1 here and then number 2 here. So the last elements would be number 3. So it's like the reverse. Instead of taking from the back, it'll take from the front. So obviously, this should be screaming base case to you because we're adding something different. So let's come up with our base case first, because that's sort of good practice. So base case, if I can type. So literally exactly what's going to be happening here. We just have to say if listo is, listo's our parameter name up here. So if listo equals an empty list, I'm going to want to return 0. And let's come up with our recursive case, because this is sort of what a lot of you guys were struggling with today. I'm going to use pop first, but I'll also show you a solution with slicing. So obviously, as you can see here, I am popping off the last elements through every call of the function. So the first thing I'm going to do is listo.pop. I can type. Wow. And then I'm going to print out what's happening with listo. Actually, I'm going to print it out before, just so I get the first iteration of my listo as well. So you guys can see what's going on here. Listo. And then I'm going to make my recursive call, which obviously we're going to have some sort of call to our function. So I'm just going to type our function right there. But do we need to change our parameter? I don't think so, right? Because we're already changing our parameter in the line above. So we can just leave our parameter as is. However, we need to keep track of how many M&Ms we're eating, right? So we simply return 1 plus the value of the call before, which as you guys can see, it's going to be 1 plus 1 plus 1 plus 0 at the end, because that's how recursion works. And let's go ahead and see if this works. It should give us the output of 3. As you can see, it gave us the output of 3, but I also printed out our list. So first, we're passed through the list of 1, 2, 3. Then I popped off an M&M and ate it. Now I only have a list of 2 elements, and then 1 element. And as soon as it's an empty list here, I return 0. So then let's look at the framework on the side here. Let's let's pick the computer's brain. So the computer now has done 3 recursive calls. On the 4th recursive call, it's like, man, I'm out of M&Ms. So I'm going to return 0. So now we should have a return value pop-up of 0. So now, because we're doing 1 plus or this is just return 0, but now it's going to return to our last function call. So it's going to be 1 plus our last function call plus our last function call until we get to our original function call. So right now it's 0 plus 1. Now it's going to be 1 plus 1, which is 2. So it's going to be 2 plus 1, which is 3. And we get our length of 3 because that's our last function call. Now we got to our original call and it just prints out 3. I'm going to uncomment these bad boys real quick just to show you that it should work for all the scenarios. And as you can see, I'm going to quickly get rid of that so we can only see the answers. And yes, 3705, as you can see, is our expected output for all of them, including my super fancy list here with several types. Now let's talk about a way to do this using slicing. And this actually gets rid of an entire line of code if you're wants to be super duper efficient. But we would have to manipulate the actual parameter, and a lot of you guys didn't want to do that, so you just went with pop. However, if you simply just imply this bad boy right here, this is going to be the sort of opposite of what pop was doing. Instead, let me print out what's happening here. Let's print out listo and sort of see what was happening like last time. I'm going to comment these guys back up so we don't have like 100 print statements, and I already do have 100 print statements, but that's okay, not anymore. As you can see, it's the opposite. Instead of eating the M&Ms from the back, the computer ate the M&Ms from the front. So it's just pretty much the opposite, but the exact same outcome of the thing before. And it should work for all these test cases. Got rid of the print there, and then, yes, so it should work for all these test cases. As you can see, it did. So obviously this was a pretty straightforward recursion assignment that you guys had. A lot of you guys finished early, which was great. But for those of you who aren't fully understanding what recursion is, I do strongly suggest you get that down as soon as possible, whether it's visiting office hours or there are a plethora of resources online. And when I say there are online resources, I don't want you guys to be just Googling, like, for instance, if you're in lab today and you got stuck, you shouldn't be Googling, like, how to recursively find the length of a list in Python. And then just, like, reiterate that code here without really understanding what you're doing, because 1, you'll get honor coded, and 2, you're not going to be able to do that in future courses or even in this course, I believe. The recursion is just going to be too specific and too hard. So you're sort of going to get left behind in a sense. So I strongly suggest you try your hardest to get recursion down, because once you get it down, you'll see that recursion is very cool.